Some basic concepts of chemistry. Chemistry is an exciting experimental science which lets us to understand our world and makes our life easier. Chemistry is at the core of every technology we enjoy today. The power of the chemical sciences is what they create as a whole, an enabling infrastructure that delivers the foods, fuels, medicines and materials that are the hallmarks of modern life. The contribution of chemical scientists and engineers are central to technological progress and the health of many industries, including the chemical, pharmaceutical, electronics, agriculture, automobile and aerospace sectors. And these contributions create new jobs, boost economic growth and improve our health and standard of living. Chemistry plays an important role in meeting human needs for food. Hence, different variety of fertilizers, improved varieties of insecticides and pesticides were prepared. We can define chemistry as the study of the composition, structure and properties of matter, and the reactions by which one form of matter may be converted into another form. Basic needs of people. Food. Food is any substance consumed to provide nutrition support for the body. It is usually of plant or animal origin and contains essential nutrients such as carbohydrates, fats, proteins, vitamins and minerals. The entire population in India can get good quality, tasty and mouth-watering hygienic food by manufacturing good quality of fertilizers and insecticides. The major factor determining the increase in food demand is population growth. As India's population increases, the demand for food increases exponentially. India is producing enough food grains, sugar, vegetables so as to become self-sufficient and maintain a big stock of food for the next generation. Clothes. Clothing is one of the basic needs of humans. The preliminary materials required for clothing are produced in nature by a cotton plant by the following reaction. CO2 plus H2O gives cotton plus O2. We produce man-made fibers like nylon, rayon, terylene, etc. and certain animals or insect synthesized fibers like wool, silk, fur, etc. Shelter. Man requires comfortable home for living. Cement and steel are required for construction of homes, for building express highways. Our country is now exporting iron ore to other countries and producing sufficient quantity of cement. Chemistry has vital role for development of these fields. Branches of chemistry. Biochemistry. It deals with the substances consisting of living organisms. Organic chemistry. The branch of chemistry which deals with the reactions of the compounds of carbon is called organic chemistry. Physical chemistry. It deals with the structure of matter, the energy changes and the theories, laws and principles which explain the transformation of matter from one form to another. Analytical chemistry. This is the branch of chemistry which deals with the separation, identification and qualitative determination of the compositions of different substances. Inorganic chemistry. It deals with chemistry of elements other than carbon and of their compounds. Scope of chemistry in different fields. Drugs. Chemistry has become an interdisciplinary science and no scientific work can escape chemistry. Nowadays, number of healthcare products have been isolated from plant and animal sources or prepared by synthetic methods. Drugs like cisplatin and Taxol are used in cancer therapy. Drugs azithromycin (AZT) was first isolated from plant and then synthesized in laboratory for treating AIDS patients. Tamiflu is used to treat the patient suffering from swine flu. Chemists devise new products and better ways to make old ones. Hopefully, the research in the field of mechanism of aging will give you a longer, healthier and happier life for people. Engineering. Metals like iron, steel, aluminium, zinc, etc. have importance in the field of engineering. Precious metals like gold, silver are extracted, purified, synthesized and analyzed using chemical processes. Energy. Coal, petroleum, natural gas are major sources of energy. Burning of these fuels produces energy which is used for driving all automobiles. But it is harmful as it increases environmental pollution and is responsible for global warming. As the population of the country is increasing, demand for these fuels is also increasing. However, at the present rate of consumption, stock of these fuels will be exhausted within the next 40 to 50 years. So, we have to develop new sources of energy which will be non-pollutant and cheaper. Scientists have developed electrochemical cells like Daniell cell, dry cell, fuel cell, etc. Abundantly available solar energy can solve most of our problems if we convert solar energy into electrical energy using solar cells. Food. Chemistry is related to food because of the chemical compounds found in all our foods. Everything we eat is made up of oxygen, nitrogen, hydrogen and carbon. The only difference is how these elements are organized in different foods, which also affects how certain foods are digested and metabolized. Trees and plants photosynthesize food in presence of sunlight. In this process, chlorophyll acts as a catalyst. CO2 plus H2O in presence of sunlight gives food grains or fruits or flowers. This reaction takes place in nature. The development of good quality fertilizers and insecticides have increased the yield. Materials. Knowledge of chemistry is useful in designing number of essential materials like adhesives, polymers, latex paints, microprocessors, liquid crystals. Historical approach to particulate nature of matter. A matter has a mass and it occupies space. Each and every substance has a unique identity and a set of characteristic properties. Different substances differ from each other in their constituent compositions and can be distinguished from each other by their appearance, taste, smell, interaction with other substances. Mixture. It is a simple composition of two or more substances in which the constituent substances retain their separate identities. The physical properties of mixture, such as its melting point, may differ from those of the components. Some mixtures can be separated into their components by physical means. Homogeneous mixture. A mixture in which the concentrations of the constituents remain uniform throughout and all the constituents are present in one phase is called a homogeneous mixture. For example, mixture of ethanol and water, mixture of gases. Heterogeneous mixture. If constituents of mixture are present in two or more phases, then it is called as heterogeneous mixture. For example, iron-filling sand system, phenol water system, mixture of all solids. The phlogiston theory. The theory stated that a substance undergoing combustion mainly contains a mysterious matter called phlogiston and clacks. If a substance is burnt, phlogiston evolves and goes into the atmosphere and clacks is left behind as an ash. In 1771, scientist Priestley heated mercury oxide by focusing sun rays on it. A gas was evolved and it was observed that substances burnt in this gas more vigorously than in air. Priestley believed that the gas is the normal air without phlogiston and named it as dephlogisticated air. Cavendish prepared a gas called flammable air by reaction of dilute acid with metals like zinc, iron, etc. The gas burnt in air and also in dephlogisticated air, forming water. He suggested that flammable air must be water associated with phlogiston. Finally, scientist Lavoisier ruled out the theory of phlogiston. Lavoisier proved that during burning, part of the air is used in the chemical reaction. The part of the air used for burning was named oxygen, meaning acid forming. He also proved that gas formed in Priestley's experiment was oxygen. According to Lavoisier, flammable air produced by Cavendish was a new gas which he named as hydrogen, meaning water forming. Elements and compounds. Element. An element is a substance that cannot be decomposed by a simple chemical process into two or more different substances. For example, gold, iron, copper, carbon. Compound. It is a substance of definite composition which can be decomposed into two or more substances by a simple chemical process. For example, sugar, water, alcohol. Units. A unit is defined as the standard of reference chosen to measure any physical quantity. A good unit must have the following characteristics. It should be easily reproducible. It should be accepted universally. The magnitude of a unit should not be dependent on the place and time. System of units. The magnitude of various properties of substances measured by scientists have been expressed from time to time in several systems of units. The centimeter gram second CGS system. In this system, length is measured in centimeters, mass is measured in grams, and time is measured in seconds. The foot pound second FPS system. This system is based upon three basic units: foot as the unit of length, pound as the unit of mass, and second as the unit of time. The meter kilogram second MKS system. Here, length is measured in meter, mass in kilogram, and time is measured in seconds. SI system. The International System of Units is the modern form of the metric system and is generally a system of units of measurement derived around 7 base units. The 7 fundamental SI units are listed below. Derived units. Units obtained by multiplying or dividing one fundamental unit by another fundamental unit are known as derived units. Derived units are given in the following table. Laws of chemical combination. Lewis' law of combining volumes of gases. Statement: when gases react together to produce gaseous products, the volumes of reactants and products bear a simple whole number ratio with each other, provided volumes are measured at same temperature and pressure. For example, under identical conditions of temperature and pressure, 1 liter of nitrogen gas reacts with 3 liters of hydrogen to produce 2 liters of ammonia gas. That is, N2 plus 3H2 gives 2 NH3. Thus, the ratio of volumes is 1:3:2. Law of definite compositions. This law was given by chemist Proust. Statement: any pure compound always contains the same elements in a definite proportion by weight, irrespective of its source or method of preparation. This law is also called as law of definite proportions. Scientist Berthollet opposed the Proust's law of definite proportion by giving examples of the substances containing different proportions of elements. But Berthollet's objections were ruled out as he did his experimental work on impure samples or incomplete reactions. Law of conversion of mass. The law states that the mass is neither created nor destroyed during chemical combination of matter. Law of conservation of mass is a relation stating that in a chemical reaction, the mass of the products is equal to the mass of the reactants. Law of multiple proportions. This law was given by scientist John Dalton. The law states that if two elements chemically combine with each other, forming two or more compounds with different compositions by weight, then the masses of two interacting elements in the two compounds are in the ratio of small whole numbers. For example, carbon reacts chemically with oxygen to form two compounds, carbon monoxide and carbon dioxide. On analysis, it was found that 1 gram of carbon reacts with 1.33 grams of oxygen to form carbon monoxide, and 1 gram of carbon reacts with 2.66 grams of oxygen to form carbon dioxide. Dalton's atomic theory. John Dalton is considered the father of modern atomic theory. His efforts gave us our first understanding of the atom, bringing it from an abstract philosophical concept from ancient Greece to a concrete reality. Assumptions of Dalton's atomic theory. All matters are made up of tiny, indestructible, indivisible unit particles called atoms. Atoms are the smallest particles of the element and molecules are the smallest particles of a compound. All atoms of the same element have same size, shape and mass and all other properties. Atoms of different elements have different properties. Compounds are formed when atoms of different elements combine. The atoms in a compound unite in small whole number ratios like 1:1, 1:2, 1:3, 2:1, 2:3, etc. A chemical reaction involves only the separation, combination or rearrangement of integer number of atoms. During chemical reaction, atoms are neither created nor destroyed. The way that John Dalton came up with this atomic theory is quite interesting. He was foremost a chemist, and his main scientific work was focused on the behavior and properties of gases. His observations helped him to discover the partial pressures of gases. This major advance in stoichiometry, the ratio of elements, leading to the formulation of a working theory of the atom. He noticed that certain gases maintain the same ratios of mixture regardless of the amount. This law of proportion led him to believe that the ratios remained same because they were consistent down to the smallest particle of the atom. Dalton also explained law of conservation of mass. According to him, the total number of atoms in the reactant and products remain same. Elements, atoms and molecules. Element. It is a substance which cannot be separated into simple substances by any chemical process. Atom. The smallest indivisible particle of an element is called an atom. Atom may or may not have free existence. Molecule. It is the smallest unit of a compound and is an aggregate of two or more atoms of definite composition which are held together by chemical bonds. A molecule may contain atoms of the same element or different elements. Atomic and molecular masses. The mass of the atom changes as the number of subatomic particles is changed. Hence, masses of different atoms of different elements are different. By international agreement in 1961 for determining atomic masses, carbon was chosen as standard with its atomic mass 12 AMU. The masses of all other atoms are determined relative to the mass of an atom of carbon-12, the standard. The observed atomic mass of the atom of the element is the average atomic mass of the elements taking into consideration the natural abundances of their isotopes. Molecular mass of a substance is defined as the ratio of mass of one molecule of a substance to 1/12 of the mass of one atom of carbon-12. Avogadro's law. Statement: equal volumes of different gases under identical conditions of pressure and temperature contain equal number of molecules. Mathematically, Avogadro's law is stated as: at constant pressure and temperature, volume of a gas is directly proportional to the number of molecules. That is, V is directly proportional to the number of molecules. P and T are constant. But number of molecules is directly proportional to N, which is number of moles. Therefore, V is directly proportional to N, or V upon N is equal to constant. Avogadro's law helps us to determine molecular weight of volatile compounds. It helps to prove that 1 mole of any pure gas occupies volume of 22.414 dm³ at standard conditions of temperature and pressure. Avogadro's law helps to determine atomicity of a gas molecule. Atomicity is the total number of atoms of constituent elements combined to form a molecule. Consider the formation of steam from hydrogen and oxygen. The reaction can be written as 2H2 plus O2 gives 2H2O. According to Lewis' law, 2 volumes plus 1 volume gives 2 volume. According to Avogadro's law, 2n molecules plus n molecules gives 2n molecules. Dividing by n, 2 molecules plus 1 molecule gives 2 molecules. Dividing by 2, 1 molecule plus half molecule gives 1 molecule. Thus, it can be stated that 1 molecule of water contains 1 atom of oxygen and 2 atoms of hydrogen that have come from half molecule of oxygen and 1 molecule of hydrogen respectively. Hence, 1 oxygen molecule must be made up of at least 2 oxygen atoms and hydrogen molecule must be made up of 2 hydrogen atoms. Mole concept and Avogadro number. 1 mole of the substance is defined as the amount of substance that contains the number of particles, atoms, molecules, ions or electrons as present in 0.012 kilograms of carbon-12. This number of particles is determined to be equal to 6.022 into 10 raised to 23 particles. This number is called as Avogadro number, Na. Percentage composition and molecular formula. Percentage composition of a compound refers to the amount of various constituent elements present per 100 parts by mass of the substance. Percentage mass of the element is equal to number of atoms of element into atomic mass of the element upon molecular mass of the substance into 100. Empirical formula. It is a chemical formula indicating the relative number of atoms in the simplest ratio. Molecular formula. It is the actual number of constituent atoms in a molecule. Molecular formula is the integral multiple of empirical formula. Let us find molecular formula for the compound whose molar mass is 159 and which was found to contain 39.62% copper and 20.13% sulfur. First, we calculate the sum of the percentages of the constituent elements. Percentage Cu plus percentage S equals 39.62 plus 20.13, which is equal to 59.75%. This is less than 100%. Hence, compound contains oxygen whose percentage of oxygen is equal to 100 minus 59.75, which gives 40.25%. Calculate the number of moles of each constituent element present in 100 grams of the substance. Moles of Cu is equal to percentage of Cu upon atomic mass of Cu, which is equal to 39.62 upon 63, which is equal to 0.629. Moles of S is equal to percentage of S upon atomic mass of S, which is equal to 20.13 upon 32, which equals 0.629. Moles of oxygen is equal to percentage of oxygen upon atomic mass of oxygen, which equals to 40.25 upon 16, which is equal to 2.516. Hence, ratio of number of moles of Cu is to S is to O is 0.629 upon 0.629, which is equal to 1, 0.629 upon 0.629, which is equal to 1, and 2.516 upon 0.629, which is equal to 4. Therefore, the empirical formula is CuSO4. The empirical formula mass is 63 plus 32 plus 16 into 4, which is 159. As molecular mass is equal to the empirical mass, molecular formula is equal to the empirical formula CuSO4. Stoichiometry. Stoichiometry is a process of making calculation based on formulae and balanced chemical equations. In the balanced chemical reaction, 2H2 plus O2 gives 2H2O. 2, 1 and 2 are coefficients of H2, O2 and H2O respectively. These are called stoichiometric coefficients. Steps in stoichiometric calculations. Write correct formula of reactants and products and satisfy valencies of atoms of the compound. Write balanced chemical equations. Names of reactants with a plus sign separating them should be written on LHS. An arrow should be drawn from left to right and then the names of all products with plus sign separating them should be written on the RHS. Rewrite the chemical equation in terms of chemical formula of each substance and then balance the mass of the chemical reaction. Limiting reactant. The reactant that reacts completely but limits the further progress of the reaction is called a limiting reactant. Excess reactant. It is the reactant which is taken in excess than the limiting reactant.